and welcome to today's webcast about virtual assessment of simulation results with VRED. My name is Antonis and I'd like to briefly introduce myself. So I'm a car designer. I studied actually transportation interior design, but I quickly found my passion for computers and 3D modeling. So for quite many years I worked on show car exteriors, and there I was mainly in charge of modeling the shape. So since then I kept the passion, and now at Product Innovation Launch I help our clients make beautiful products and have the right software and skills to do that. Let me also tell you a little bit about Product Innovation Launch. So Product Innovation Launch was founded by Christian Pilgram, who's also a product designer, in 2005. We're situated here in Langenargen at the beautiful Lake of Constance, and since last year we are part of MF Software Solutions. They are also, as we are, an Autodesk reseller, but they are focused on injection molding simulation. So together we support our customers with their workflows, no matter if it is the right license or if it is training their staff to be able to use the software to the max. So talking about the software, let me quickly give you an overview what we're talking about. So MF Software is reselling Autodesk Moldflow, and here in Langenargen the IDNV means Industrial Design and Visualization Studio. We are focusing on Alias and VRED. So I want to talk about Moldflow, although I'm not the expert in it. Moldflow is a software to simulate injection molding and all the different ways of doing that. I'm not the expert. I'm happy that Ben Wittmann is also on this webcast. If you have specific questions about that tool, please ask him later. But basically, yeah, that is my understanding of the software. And I know much more about Alias. So Alias is a surfacing software to make beautiful shapes, and basically it covers the main two parts of the workflow in design of concept modeling and class A modeling. So concept modeling basically means making a shape that can quickly be changed to react to design changes to catch the feeling that you want. And class A modeling is basically the process when the main design is set and you want to get the high quality surfaces that you need, especially for high gloss surfaces as you have in car design. Of course, therefore you need the right tools, and Alias is offering the tools to create surfaces, but also to evaluate surfaces the best way possible. And because Alias is a standard in automotive design, it has many possibilities to exchange data with industry standard software, which is a good thing when working together with other departments. So let's go over to VRED. So VRED is also industry standard in the automotive design. VRED, as all the renderer engines that are out there, is able to actually give you real-time presentation or real-time visualization right out of the software, as you see here. But of course, VRED can also render out still images and videos if you need them But what's very unique about VRED is that firstly, it is capable of importing a lot of industry standard formats, so you don't need to use converters in many cases, but you can just drop it right into VRED. And the other good thing about VRED that is very capable of large data sets. So for example, when working with Unreal Engine, there's a lot of data prep needed to have a high performance in Unreal Engine, but in VRED you basically don't have to do too much data prep to have a good scene. VRED provides all the necessary tools to evaluate an object in 3D, so it has various tools to evaluate surface quality, to measure, and also to simulate light and reflection. And also a good thing, which you kind of see here now, is that you're able to individualize the experience. You can make your own interface, and you can also make custom scripts to adapt to your workflow. I also want to introduce to you our partner Ideenkultivierung. Ideenkultivierung is a studio run by Christian Wölfle and Christopher Gebhardt. They are both experts in visualization, but specifically also in VRED and programming with VRED, and therefore they were the perfect partner also in this project to investigate how such a solution could look like, especially also Christopher Gebhardt, who is capable of programming to make things look as we need them. So let me explain you the challenge that we find, just for your understanding. So we didn't made this up just our own. We actually were in contact, in discussion with first-tier suppliers for injection molded parts in the automotive industry, but we were actually also in talks with OEMs about their difficulties with their process. And basically that's the summary of what we understood how things go. So I tried to make it, of course, very simple, so please don't be mad, but if you have any comments about my summary, let me know. So on the left you have the designer, the artsy guy who wants to make a beautiful product, and on the right you have the engineer who also wants to make a beautiful product, but who wants to make it work too. And from designer's perspective, basically you start from zero and you start sketching and trying to get closer and closer to the perfect design. And in the beginning, of course, the steps are very big, and then the further you go, the more it is basically about improvements. And therefore, at some point in the process, there is a design freeze, basically saying that from now on we're just gonna improve the themes. So the main design theme is set, also the engineers can start work, and we just try to keep the main design topic and improve design quality in all corners. And additionally, or more from the engineer's perspective, basically you have the production maturity, which means like how producible is the car actually. And of course engineers are involved in the processes from the very beginning, but I would say like in the beginning it is highly a consulting job, and the further you go, the more intense it becomes, especially after the design freeze. The engineering ramps up, and they try to make everything being producible and work and meet regulations and be functional, and hopefully in the end they all end up in the perfect product. The point is to have the first prototype of basically the mass-produced parts. You have to have all engineering being done. So from the Class A surfaces, there have to be made parts, and the parts, of course, they need to have all geometry that make it stiff, and all the mounting points and everything that makes it a proper part. And from there you have to make the tools, and then you can make the first sample with the machine, which is the golden sample And with that golden sample, you can then go into the process of cubing, which is basically making a first prototype out of those samples. And at that point, you have your first visual review of how your product is gonna look like in mass production. And as you can see, this is fairly late in the process, and this graph should show you how the surface quality develops. Don't take it too serious. I just want to emphasize what challenges come up for the surface quality of a product, specifically a car. So basically the surface quality until the design freeze improves, and then of course there starts the challenges that certain aspects have to be taken care of. It might be regulations, it might be for parts, for collision of elements in the car, and then you have to react with changing these surfaces. So the surface quality might go up and down, and then there comes the critical point of the golden sample where you see, all right, I mean, it might be that the surface quality meets your expectation, but it might be that the injection molding actually changes the surfaces in a dramatic way, and then you need to address that, and in best case you make it happen and you get back to your envisioned surface quality. Just for your information, of course, like talking about injection molded parts in the automotive exterior, we're talking mostly about front and rear bumper, because they are high gloss there. Also, the surface quality matters the most. So summing up, we think that the design and manufacturing processes are not synced perfectly, means that of course the engineer has to take care of making the car producible, and the designer wants to make the design perfect, and therefore often it's difficult to sync them both, that they can work together on the perfect result which they both want. The second big point is that the visual review begins after the first physical part is being produced, so it's fairly late. The designer's probably already working on the next project, and that's the third point. The engineer now has little to no time to make the changes happen, and the tools are already made, and then it's also expensive to do those changes. So we thought about what might be helpful to tackle those challenges, and we thought about 3 points. The first one being provide visual feedback already in the early phase, which would help the designer and the modeler to understand what's going to happen to their design. Second, it adds high quality visualization to the tools of assessing the final product, which I think helps a lot, because from what I've seen, the heat maps and numbers that show the deviation between certain points in the Strag and the simulation might show in numbers what's happening. But especially for designers, and I think also for the consumer, for the perception of quality, the visual quality, how the reflections work on the car, are very important, and that should be a very critical part of the tool set. And third, I mentioned it before, I think the sooner we can see the challenges, the earlier we can start address them, try to find solutions, and I think that's firstly easier, you have more time, and I would say it's also cheaper to tackle those digitally rather than when the tools are already done. I would also like to quickly explain you in simple words how we imagine that's going to work. So basically you have your surfacing in Alias, which is providing the initial class A model, but it's also the correct software to remodel parts, because there you can really handle the surfaces in the way that is needed. On the other side, you have Moldflow, which is providing the informations for experts, but also delivering the simulation files for VRED. Of course, like Moldflow could also deliver that geometry to Alias, so the modeler there knows where to change stuff. That is of course also possible. But most importantly, and the software that we're gonna have a look on today, is VRED, because VRED, in our opinion, can be handled in a way that serves as a platform for communications for everybody. So we think that VRED can be set up so anyone can use it, no matter which skills he has. We think that this is a tool to make the visual evaluation accessible to everybody, and because I said, like, anyone should be able to use it. It is decentralized, so you don't need to have an expert from one department, but it doesn't matter where you sit, you could use that file to have a discussion. So let me jump right into the software. So now we are in VRED, and before I explain to you further, I just want to address that this is a demo geometry. So Ideenkultivierung actually made a pilot project with a first-tier supplier of injection molded parts using proper production data and scans of it. But as you can imagine, because of the data being confidential, they couldn't share the data with me for this presentation. But I think the geometry will still show what this tool is meant for. So VRED, especially with the interface that Ideenkultivierung developed, is fairly easy. You can of course navigate around the scene with your mouse and see already how the reflection react on the car. This is a typical studio setup with a lot of light lines on the roof. This is how basically many design studios look like, exactly for that purpose. But of course you have easy access here to other environments that can give you also a more realistic impression of the reflection and of the part, which can be very helpful. Also, you have the possibility to change the different surface finish that you would like to show. So if it's color or also finish, that is easily accessible. And the next thing that helps evaluating the surface or maybe a specific problem area is setting up viewpoints. So here we predefine some points addressing that we want to talk about that specific area, and then we can toggle between those perspectives. And actually those viewpoints are very easily set up, so of course that could be easily done in-house by you, but of course, like, if you would be interested in using such an interface or such a scene, we can help you preparing that. To show you one of the analytic tools that you get with VRED, you can change the visualization mode, which now flipped from realistic to analytic, and now you solely see reflection lines. You can also set up the repetition of lines, you can set up the thicknesses, but in that case we set it up like that, and that further helps evaluating the surface quality. And last you can set up animations. If you ever had an appointment with a designer on a car, I bet you've seen him going back and forth with the head to see exactly what we're seeing here, to have an impression of how these reflections run across the surface. Exactly, and you can set up different animations. Of course, we can set them up for you. That's no problem, and I think that is a good base to have an objective discussion and everyone sees the same. Yeah, so basically what can we do further? So we have also this window down here where you can toggle between the geometry. In that case, we made a scan geometry that you could compare it to. It could also be the simulation, but as I told you, as this is demo geometry, we don't have simulation data for that. And now you can compare how the difference looks like, that you have a dent, for example, here, and compare it to the original geometry. And then you could set up different steps to see how much you have to change your geometry to actually come to such a point, and then start discussing, okay, how do I address it? And then of course you can load in more alternatives that tackle this problem from Alias, and then simulate them again in Moldflow, and then have a look on it here in VRED again. So basically at the moment we are looking for a partner to make up demo files, so we can show better how that would work in real life. As I said, currently because of the confidentiality, we couldn't do that. But we would really hope to be able to do that, because we think that it makes sense to have a look on geometry in such a way. Also very interesting is to see such parts in the context of the whole car, to see how reflection influence the perception of consumers and possible buyers of such a car. Exactly. So furthermore, I wanted to show you just to give you impression. So this is the interface that we made. You can also hide that menu if you want to see more of the car and less of the menu, and this further helps to make a good experience for your meeting, talking about the parts. Also, what I find very interesting is the possibility to actually use such a scene in on any device. So there's many possibilities to use VRED. Now I opened it in a browser, so you could, for example, run such a scene in-house on another device like a tablet. And because of the simplicity of the interface, I think anyone would be able to use it. And exactly, so I just wanted to quickly show you that how we narrowed down the interface from VRED being a very professional tool, having many options and many tools to make it happen. We have the scene graph where all the geometry is set up. Of course, like we have all the materials in the scene. We have the VSets, is basically the organization of all the alternatives and variants that we are switching here in the menu, and basically our custom user interface for the scene that we set up. So That's basically it about my presentation. I want to thank Ideenkultivierung again for their support for this presentation, but also for their work on this project. As I said, I would be happy to talk to you about it. If you're interested in making such a prototype with your geometry, we would be happy to support you. Thank you.